Hey guys, welcome back to the channel. We're gonna work on batteries today. Well, parallel and series. As you've seen my other videos, we've had 5 batteries and only 2 of these are good. The 1310, which is the constant nominal voltage, and we have our 1303. Again, when we put these in parallel together, this voltage will equalize. They're not too far apart, which is nice. The rest of these are scrap. Also, this battery is actually in series. You have 6 cells, 2 volts each. Together in series gives you the nominal voltage of 12. So we're gonna do battery hookups for series, 12 volts. And we'll start off with one battery.
2, 3, 4. And each of these will be 12 volts. And each of these is 10 amp hours, 10 amp hours, 10 amp hours, 10 amp hours.
And when they're linked together, which we'll get to in a second, so you have your negative wire going out. This marker's dry. There we go. And we have our positive wire going out. We have to link these together. So that's negative, positive, linked into the negative, positive, linked into the negative, then positive, linked into the negative, which is then obviously going out to the positive. So you have 12, 24, 36, and 48 volts. So it just keeps increasing. Now, when you're drawing this much power, say this battery is completely empty. So we have a box that will show you how this happens. So this battery is now completely empty. The load was all on it. And as you go through here with it, because the battery is so close to the end, the amount of power going out is everything the battery has. So now we're empty. This battery here will come down a third. Sorry, it'll come down let's go 3/4, makes it better for this drawing. This will come down a half, and then this will only come down a quarter. These batteries will begin to, if it's left alone, it'll start balancing out and it'll fill up the last battery to create a normal voltage and amps going right across. The amperage does not increase, but the voltage does for your application. So this is only 12 volts. This changes when you have a parallel circuit. You get the same voltage, so the same 12 volts all the way across, but the amp hours change. So we're gonna use 4 batteries again to hook them all up in parallel. We'll do this slightly differently because the diagram will be a lot different. So we're gonna have the batteries, negative, positive, negative.
Positive, negative, positive, negative, positive.
I know it looks kind of crazy. I'll show an actual video of doing this to prove my point. You still have 12 volts, even though there's 1, 2, 3, 4 batteries. They're all running at 12 volts, so you get 12 volts only. The difference is these are all combined together. So you have 10 amp hours, 10 amp hours, 10 amp hours, 10 amp hours. So 10 amp hours times 4 equals 40 amp hours. So you have this with an inverter and you have a longer time for running that. The beauty, like you could do this a whole different way, a few different ways. I'll show another one in a second. It's the unbalanced version of this. But basically, with the negative being on this side and the positive being on this side, your load is balanced between all the batteries so that your 4 batteries, as they drain, they will drain equally. So if it drains a third here, it'll drain a third here, it'll drain a third here, and it'll drain a third here, keeping all your wires the same length is also good. Now, when you have an additional style of parallel,
it's just a quick one. So positive, negative, positive, negative, or negative, negative, positive, negative, positive. These are linked together. These are linked together.
and then these get linked together, these get linked together, and the opposite will be true for my other markers dying. So positive side is now blue, and then negative is linked together, negative is linked together, negative is linked together, negative is linked together, and that's going out that way. So these are all linked together in parallel, and because they're all linked like this, they will drain not as equals because they're not crossing each other. This one's still better. You could do a lot worse. Now the worst one is when you have your first battery.
Negative, positive, negative, positive, negative, positive, negative, positive, and the battery does this. From here, right here, and then right here, and then out. Whereas this is the opposite, and then out. That's the worst, because these will all
Drain first here, then that one would be about half, this one would be almost empty, and this one would just be a third. Like, it'll drain horribly, and you'll have to mix and match your batteries around to increase and keep the longevity of all the batteries. Whereas you'll have to replace these ones, these batteries still be viable. So having a balanced battery setup is paramount. So that's what you want. This is kind of the same thing, but this is horrible because you have this battery right at the end that doesn't get touched, whereas the one at the beginning gets used up first. I know we just covered hooking up your batteries in series, how it increases the voltage, and we covered hooking up your batteries in parallel and how it keeps the voltage the same right across, but increases the amp hours. But what if you needed twice the amp hours and twice the voltage? Let's say you're using 6 amp hour batteries with 6 volts per battery. What would that look like to get 12 volts and to have 12 amp hours? And what about series plus parallel? What if you combine the two? Let's use that theory, that idea, and put our pen, marker to paper. Same 4 battery, and we're gonna do the bird's eye view again. I like that view best. We're gonna use 6-volt batteries with 6 amp hours each. So the first part of this, we're gonna put them in parallel. So we're gonna take that 6 amp hours and increase it to 12 amp hours just by putting them in parallel. Therefore, keeping the same voltage, but adding the amp hours up. I think you can see where I'm going here. The next part of this will be putting it in series to increase the voltage from 6 volts to 12 volts total. The series and parallel together can be a combined circuit to give you exactly what you need for your battery array. So thank you for watching, and if you have questions, comments, concerns, please leave them down below. I'll get back to you guys as soon as I can. At the end of this video, I will throw up a couple diagrams that I quickly found online that you can just pause and use for your own references, because my drawings were kind of messy and the black marker decided to vacate halfway through this. Peace. This is your battery array in series, 12 volts, 4 of them equaling 48 volts. This is your parallel battery array, only adding amp hours. So if you have 12 volts for the battery, it's 12 volts for the array. This is those same 12 volt batteries in a balanced parallel setup. And finally, this is your series and parallel together.